This meeting is being recorded.
So, welcome and good afternoon to all. And we are delighted to welcome Dr. Tabish Alam, Senior Scientist at Central Building Research Institute, Roorkee, on the third day of our Faculty Development Program. And Dr. Alam brings extensive expertise in the field of building science and the sustainable development. And today he will share his insights on the building energy efficiency pathway towards net zero buildings, a topic of the critical importance in shaping the future of climate response and energy smart infrastructures. We look forward to an engaging and enlightening session filled with practical knowledge, research perspectives, and innovative solutions for achieving the energy building environments. And so now I call our fellow coordinator, Dr. Subham Meena sir, to briefly introduce the expert to the participants. Subham Meena sir, please introduce the experts.
Thank you very much, Dr. Ravi sir, and good afternoon, everyone. It is my great pleasure to introduce our esteemed speaker for this session, Dr. Tabish Alam, Senior Scientist at the CSIR, that is Central Building Research Institute, Roorkee. Dr. Alam is a leading expert in heat transfer enhancement, solar thermal systems, computational fluid dynamics, and building physics. He holds both a PhD and MTech in thermal engineering from IIT Roorkee and BTech from Aligarh Muslim University. His research career includes postdoctoral work at IIT Bombay and Kyonpok National University in South Korea. Dr. Alam's contribution to sustainable energy and thermal engineering have earned his significant recognition. Most notably, he was named among the top 2% scientists globally by Stanford University in 2024. He is also a recipient of several prestigious honors, including the Diamond Jubilee Best Technology Award for an innovative HVAC ducting system integrated with COVID-19 disinfection, the Sarthi Sharma Sanyal Memorial Award from the Best Paper in the Journal of the Institute of Engineering, Series A, published by Springer. Dr. Alam is actively shaping national standard as a member of BIS Committee CHD27 on thermal insulation material and contributes a global research community as associate editor of Thermal Science and Energy Systems, Energy Efficiency in Buildings and Urban Environment, uh, Journal of Engineering, and a member of editor board for scientific report by Nature Publishing Group. With a vast body of work published in high impact journals, Dr. Alam is at the forefront of energy efficiency and thermally optimized building system. We are honored to have him here today to speak on building energy efficiency pathway towards net zero buildings. Please join me and warmly welcome Dr. Tabish Alam.
Hello,
Thank you.
I am audible.
Yes, sir, you are audible, sir.
Okay, thank you, Dr. Ravi and Dr. Meena, for introducing me. So, today's my lecture is based on the building building energy efficiency that lead to the net zero building. That is the demand for the current scenario. So, I will share my presentation. So, it is visible. Hello.
Yes, sir. Yes, sir. Yes, sir.
Okay. So basically, building energy efficiency is the important parts of the building that we need, that is in huge demand in the current scenario, as we are rely on the fossil fuels and other energy that's come from the fossil fuels like nuclear energy, coal, crude oil, So our aim to design a building that do not depend on these energy sources and that do not emission when these buildings do not have the carbon emissions. So the main building energy efficiency, that energy efficiency refers to use the design strategies. So there are many components for designing the improve the building energy efficiency, that design strategies, efficient technologies, operational method to reduce the energy consumption of the building, while maintaining the comfort level in the indoor environment. So basically these are the basic requirement for the any green building or any net zero building. So why we need this building? So first one is the environmental impact, economic benefit we have from the building energy efficiency, enhanced comfort and health, energy security. So these are the four parameters that can fulfill for the requirement of the building. So environment, a green building, that building are significant contribution that do not contribute to the greenhouses gas to the environment. So it has the economic benefit, energy efficient building, lower operational cost. So basically the huge consumer of the energy in the building is the HVAC system. So we have to operate the HVAC system in such a way that can reduce the energy consumption, or we can eliminate the need of the HVAC system. Third one is the enhanced comfort and the health. So indoor air quality is the main concern. Like we have seen the COVID pandemic, where we have lot of disaster has been we saw. So the energy efficiency, indoor air quality, that we have the domestic AC or the HVAC system where we have the recirculating air. So we need the design of the building in such a way that can take the fresh air while reducing the heat load or cooling loads. The fourth one is the energy security, the reducing the overall energy demand of the building, that helps decrease dependence on the external energy sources and enhance national energy security. Basically, in these chart, you can compare the energy consumption in the commercial building and the residential building. So you can see in the commercial building, the energy consumed by the HVAC, around 40% energy is going to be consumed in the HVAC, heating, ventilation, and air conditioning, and a small part like water heating, lighting, electronics, refrigeration, and cooking, and other equipment that takes a small amount of the energy. But this ratio of the HVAC in comparison to the other uh, energy consumer into the building is too high. Yeah. Similarly, we can see in the residential building the HVAC component is too high. It is around 36%. Rest of the water heating, lighting, electronics, refrigeration, cooking, and other minor equipment. So basically, the HVAC, for not only for the cooling but also for the heating, this this system required the huge amount of the energy. So basically, in this chart, you can see how the building sector is progressing in India, not in India, but in the entire world. So you can see in 2020, 2005, there is a huge uh, demand for the construction in the building. You can see there is a around 10 times of the energy building sector is growing from 2005 to 2030. So basically, what is the need? What is the strategy? Actually, we have two major measures that can reduce the energy consumption into the building. That one is the passive measure, that which can reduce the energy consumption into the building by reducing the heat load, reducing the cooling demand, reducing the energy uses of light by using the natural daylight, reducing the energy used for heating water, good housing and pupil solution, reducing the energy requirement for the ventilations. So these are the basic parameter why designing operating in appropriate way into the building, that 40% energy consumption into the building can be reduced, and rest of the 60% energy we can taken from the renewable source. So in this way we can achieve the net zero building, 100% grid independent net zero building. So, in the previous slide, we have discussed the passive techniques and the active techniques. So, the passive approach that reduce the need of the mechanical heating and cooling through the design and construction technique. So, basically, in this passive technique, the major component of the building comes like envelope of the building, where we have the insulated wall, insulated roof, and natural ventilation, where we do not need any energy input that required for run the building. So these building envelope, smart glazing, and insulated roof. So these are comes into the category of the passive parameters. In the active parameter, that the system comes into this category in the active technology like uh, e- efficient HVAC system, artificial efficient lighting, efficient equipment. So these techniques that involve using the energy to save by efficient equipment, such as through the mechanical system or technology driven solution or integration of the renewable energy, that come into the category of the active system. So these two parameters combine together to form a green building or net zero building. So basically in these energy saving in the building, that energy saving, how we can save the energy into the building, that the by designing the proper building envelope design, the means of the building envelope is to reduce the heat transfer from outside to the building or building to the outside. So this it's restrict the heat transfer from building to outside and outside to building. So it's basically reduce the HVAC load. The other point is the heat storage system. We can store the heat into the building, and then we can utilize when we are need. So passive strategies that refer to the building physics, in which the building geometry, natural daylight, natural ventilations come into the category. So building in geometry is an important aspect of the building, which can reduce the solar heat gain into the building. Natural lighting, the maximum amount of the light we can get through the glazing. And natural ventilation, this come to reduce the load due to energy, due to the low energy, due to natural ventilation can reduce the heating load or cooling load. So these passive sustainable design that can be put together into the building, so it reduce the energy consumption up to the 40%, and remaining of the active strategies that we can
Hello, Tabish. Can you hear me?
net
I
zero
think
net
we
energy
have.
consumption over here. So
Sir, your presentation
green
is not
building
visible.
basically the it is visible.
Yes, sir. Now it's visible, sir.
Okay. So basically, green building, net zero building, and not net positive building. That's the every green building can be a net zero building or net positive building. But the net positive building or net positive building, net zero building is the building that can generate the same amount of the energy that can be consumed in the into the building. But net positive building, when the we are generating the energy in comparison to the consumption of the building, that the net positive building. So every green building may be a net positive, net zero building and net positive building, but every net positive building or net zero building cannot be a green building. So basically these are the roadmap to achieve the net zero building. So basically few major consideration is important for achieving the net zero building. First is the building physics, that's come into the category of the max passive strategies. The maximum energy efficiency, the maximum energy efficiency comes into the category of the active technology, the renewable energy, and the active strategy is itself. So in the passive building physics, there is a number of the parameters which can be considered to reduce the heat load of the building, like building massing, solar orientations, building envelope, natural ventilation, natural daylight, cool roof, night radiative cooling, low energy materials, and low carbon materials. They are the important parameters that can be considered to reduce the heat load of the building. So suppose we if we have the perfect insulation of the building envelope, or roofing, perfect insulated roofing, so we can restrict the heat transfer from outside into the building. So this is the it can reduce the heat load that by reducing the heat load, we can use the uh, low capacity of the HVAC system. Solar orientations, it is also important. Solar orientation, because in the daytime we maximum of the solar gain is received in the building through the south facing. So south facing should be in such a way that there is no glazing is there, and building envelope itself is a very potentially, we can say that it is has a very potential to reduce the HVAC system natural ventilation. So by using the natural ventilation, we can reduce the heat load or cooling load, or we eliminate the HVAC system. Natural daylight, so natural daylight, maximize the natural daylight to reduce the artificial lights. Cool roof is one of the major parameters that can reduce the heat gain through the roof. Night radiative cooling, low energy material, low carbon. These are the important. These are the important parameter. These are the important parameters that come into the that's come into the category of the passive strategies. That these important parameter plays a very important role for designing the building envelope, or natural daylight, or natural ventilation, and material wise, how it is carbon emission is there into the from the building. So to maximize the energy efficiency, we can use the geo exchange ventilation, energy recovery, efficient lighting and control, intelligent building automation system, shower drain, heat recovery. So we can integrate the renewable energy, wind, geothermal, biomass, BIPV, the active strategy that HVAC system radiant cooling, heating, grid connected plug, load control, cogeneration system. So these, by implementing these technology, we can get the net zero building or even the net positive buildings. So these are the strategies, the in the passive solar design or orientation, and the window placement, that is very important. Window placement should be in such a way that in the summer it reduce the heat gain into the building, but in the winter it can provide to the maximum solar gain into the building that can be maintain the high temperature into the building. So these are the very important parameter window placement, and shading devices also plays an important role for in the building envelope. So these are the three important parameter: orientation, window placement, and the shading devices. In the building envelope, insulation, air tightness, and the double or triple glazing. Basically, the insulation, the restrict the heat, air tightness. If we have a natural ventilation or we have a perfectly 100% HVAC system, so the infiltration of the air can increase the heat load. So buildings it should be designed in such a way that reduce the air infiltrations. Glazing, double glazing or triple glazing, that can help to increase the solar intensity into the building, but it can reduce the heat load. Natural ventilation, cross ventilation, stack ventilation, and the ventilation towers. So these technique can be helped to use the natural ventilation into the building. The other point is the thermal mass. Basically, uh, thermal mass of the building plays important role not in the heating but also for the cooling of the building. So basically, thermal mass into the building in the form of the tombe wall or thermal mass high uh, uh, specific heat have to reduce the heat transfer from outside to inside the building, that delay into the heat transfer from outside to inside into the building. The next point is the shape and the layout. The basically shape of the building is important and layout is also important. The compact design, that the surface of the building should be minimized in comparison to the volume of the building. So the less amount of the surface area, so minimum heat transfer area. And zoning is very important, because zoning plays important role in the HVAC system. Suppose we have a small hall is there, and we have only few person is sitting or working there. So we generally cool the entire hall, but in the zoning we cool the uh, zone in which the person are sitting is there. So zoning is important. Design of the zoning in term of the HVAC system is very important. Green roof in the walls, that maximum amount of the solar gain is transferred through the roof. So these green facade of vegetated roofs help to reduce the solar gain into the building. So these are the pictorial view of these technology. So we can see here these are the uh, thermal insulation which restrict the heat transfer from outside to inside into the building. This one. So basically, it's not only help into reducing the cooling load, it also help to reducing the heating load. So this is the glazing into the building, that the purpose of the glazing is to transfer the natural daylight into the building, but it restricts the heat transfer from inside to outside to the building. And this is the it shows the natural ventilation strategies. In the natural ventilation strategies, we need the natural ventilation for the proper oxygen. Like in the scenario of the COVID pandemic, we need the proper ventilation is there, but we due to heat air exchange, we have to increase the heating load or cooling load. So we need to the heat recovery system that can recover the heat and maintaining the fresh air incoming to the building. The other point is the air tightness. Air tightness basically the reduce the infiltration. It does not transfer the heat directly from building to the outside. It should be through the heat exchanger. The last point is the thermal bridge. Basically, thermal bridge in the form of the steel rod or bars generally used in the building structure. So it is a high conductive material. It can increase the thermal conductivity of the component. Thermal thermal conductivity of the building component. So our aim to reduce the or minimize the use of the steel, so we can reduce the thermal conductivity of the building wall or the building component, so we can maintain the heat into the building. So that affect the HVAC capacity of the HVAC systems. So basically, these are the active strategies where we can use these is, strategies in combination with the passive strategy. So first one is the renewable energy. So we can use 40% about the 40% of the solar energy can be reduced by using the passive strategies, and rest of the 60% energy can achieved by the integration of the renewable energy like solar, wind, geothermal, and by using the uh, efficient heat pumps, variable refrigerant flow, and ERV. And we can use the natural day lighting in combination with the natural artificial lighting, day lighting, harvesting, and occupancy sensors. We can also use the generally use building automation and management system for controlling the equipment into the building like HVAC system, natural artificial light, and the other equipment. So when we need it can on, and when we do not need these systems, so it can be off automatically. So if we now we have the other equipment that comes into who comes with the energy efficiency appliances, which comes with the star rating appliances, like we have the ACs, we have the washing machine, we have the refrigerator. So we can use the high star rating that's come uh, that's provided by the various companies nowadays. So we can use the high efficient equipment. Other is the on-site energy storage. Though we can store the renewable energy in the form of in the battery on the heat storage. So uh, excess amount of the energy can be stored, and when we can use when there is no energy supply is there, or even we can even use in the night time. So basically, in the renewable energy, it is of the different forms. Wind turbines can generate the wind energy, natural daylighting, energy efficient equipment, geothermal cooling, heating, biomass, solar water heater, PV panels. They they are the green source of the energy. They do not affect the environment, and they do not emit the CO2 emission. CO2 emission is not there. So these are the basic advantage of the these renewable energy sources there, but the initial cost of these system are is too high. So basically, generally, the people are getting awareness about these renewable energy sources these days. So these renewable energy source that can be renewed time to time, that do not like fossil fuel like crude oil, they can be finished after few years. But the renewable energy sources, they do not finish by the nature can renewed further again and again for the next usage of these renewable energy sources. So first one is the solar energy. Solar energy, basically the huge potential of the renewable in the form of the renewable
This
energy. You
meeting
can
is
see
being recorded.
this in this chart you can see the solar energy potential worldwide has a great potential, not in the world, but even the major most of the part of the India. You can see in the Leh Ladakh region and the Rajasthan region, there is a maximum solar radiation is there, and rest of the amount there is a good amount of the solar radiation is there. So we can harness the solar energy into the form of the electricity, into the form of the thermal energy, into the form of the different energies we can utilize in the buildings. So basically, the solar energy that we can use into the building, in basically it is of the two forms. That one is the photovoltaic that can generate the electricity, and other is the solar thermal system that can generate the solar thermal energy for use application into the building. So basically, the generation of the electricity can provide electricity can provide into the building. That is the main component of the energy that can be used. But we can also use the thermal energy into the building also in the form of the hot water, in the form of the uh, cooling, in the form of the heating, uh, in the form of the different we can use in the different system, such as hot water heater, such for the heating the building. So basically, solar power generation by the PV panel that can generate the electricity. It may be used by the two method into the building. That one is the off grid method, one is the on grid method. Off grid method is the method in which we do not have the grid in those regions where we don't have the grid system is there. So we can have the solar panel, we have the inverter, we have the battery bank. So maximum amount of the solar energy is can be stored into the battery, and rest of the amount of the energy is can be transferred to the building. So basically, in the off-grid system, we have the grid. We can supply the generated electricity from the PV panel to the grid, and when we have no solar energy, we can take the energy electricity from the grid. So in this way, we need the solar energy. It can be utilized into the building. So it has their own advantage and own disadvantage. So uh, off-grid system are suitable for those areas where we have no grid and the remote areas, and on-grid system we can utilize in the area where we have the grid. So basically, these how can we utilize the thermal energy into the building? So these thermal energy build into the building can be utilized in the form of the hot water, in the form of the thermal energy. So basically, the solar thermal collector that can convert the solar radiation into the thermal energy in the form of the hot water, in the form of the hot fluid, in the form of the phase change material, thermal energy of the phase change material. So basically, in this diagram, we can see basic solar thermal system where we have the very simple thermal collector is there. So we have glass cover is there, we have the absorber, we have the tube in which the fluid is flowing, we have the housing is there. So in this simple thermal system, we have the solar radiation is falling on the absorber plate, and this absorber plate is getting heated, on which through below this absorber plate there is a tubing system is there. So in that the hot water is flowing, which extracts the heat from the hot water from the absorber plate. So basically these are the basic energy balance of the solar thermal system. So we have the two component of the solar energy in the form of input energy. One is the diffuse radiation, one is the direct radiance. So apart from the induced input energy in the form of solar energy, there we have a loss like conduction loss 2 to 5%, refraction loss 2 to 5%, we have convection loss 2 to 5%, and we have the heat gain to the thermal heat transfer fluid, and we have other loss like natural convection losses to the environment, we have the convection losses So there is a number of loss there, but up to 60% of the energy can be absorbed in the form of the thermal energy and can be stored into the solar thermal system. So basically, these are the basic diagram where we can see where is the heat energy is there, where is the thermal losses is there, where is the optical losses is there. So you can see optical losses is 10 to 80%, and there is the this portion is the thermal losses. This is the heat gain into the building. There is a basic equation where we can predict how much amount of the energy is going waste and how much amount of the energy being utilized. So these are the basic equations. So so we can calculate the thermal efficiency of the system where we have the input energy, where we have the useful energy. So basically these efficiency based on the overall heat loss from the system. So in the previous slide we have seen that the U value plays an important role in the for the in the environment, heat loss in the into the environment. So the top loss heat coefficient, the overall heat loss coefficient is the summation of the top loss heat coefficient, back loss heat coefficient, and the edge loss heat coefficient. Out of three, the major component may hike the value of this the overall top loss heat coefficient. It is about 60% of the overall heat loss coefficient. So maximum heat is going waste into the environment by means of the top loss glass cover. So there is some other formulas for calculating the net efficiency, effective efficiency of the collector, exergetic efficiency of the collector. Basically, to to increase the heat performance of the thermal system, we have different technologies, we have different techniques like multiple glazing that restrict the top loss coefficient, but it reduce the heat transfer and radiation that reaches to the absorber, that it is not effective way to maintain the radiation reaching to the absorber. Transmittivity of the glass. So transmittivity of the glass plays important role, that low iron glass, low solar glass can be used to uh, utilize the maximum amount of the solar energy that uh, transfer through the glass cover. Low absorption of the solar radiation by using the anti-reflective coating that reduce the reflection, reduce the reflection of the coating, reduction of the reflection. High absorptivity of the absorber plate turbulators by using the turbulators. Passive thermal system. Passive thermal system. Basically, passive thermal system in are those thermal which do not require any energy input to run the system. The entire system is run on the solar energy. So these are the active system. Active system are those thermal system. In those we need the electric power to run the system in the form of the to run the pump or the other system is there. Sorry. So these there is a major difference between the active thermal system and the passive thermal system. So the active thermal system that uses the pump to circulate the hot water, they consume the energy in the form of electricity. So basically, spend electricity to lower the energy saving. So basically, the purpose of to use the pumping system to extract the maximum amount of the solar energy. So, but in the passive system, we don't have any circulatory pump, so it's circulate the fluids by the means of the density difference. So basically, these are the flat plate collector we have developed at the CSIR, CBRI, which can be integrated into the building. So basically, these flat plate system, we have two flat plate system. One, we have flat plate system with the double glazing, and this is the single glazing flat plate collector is there. So this is high efficiency, high temperature solar system that is developed at the CSIR CBRI. Uh, Research grade solar uh, heating system developed at the CBRI with the collector efficiency above 60%, where we have the outlet temperature of the water is 80 degrees centigrade. The uh, maximum temperature in the tube is reaches up to 95 degree, and sometimes it reaches above the 100 degree what then the water can boils. So these are the few results of the single glazing and the double glazing collector. So there is, it is the blue line, it shows the efficiency of the double glaze collector, and black line shows the efficiency of the single glaze collector. So you can see there is a difference. The efficiency varies from 40% to the 65% for the double glazing, and you can see the efficiency of the single glazing from 5% to the 50%. So there is other chart is there which can show the overall heat loss of the double glazing and the single glazing by utilizing the multiple glass to double glass double glazing. So we can reduce the overall heat loss to to minimize the heat loss to the environment. So these are the few data which we have plotted in this on this graph. So these are the some other result at the efficiency of the this double glazing flat plate collector at different solar intensity. So by increasing the solar intensity, we have increased the efficiency of the system. There is a gap between the solar radiation effect of the gap into the multiple glaze. The vacuum flat plater is one of the amazing technology that we don't have we have the vacuum in between the absorber plate and the glass cover. So due to elimination of the air, there is a vacuum is there. So there is a no natural convection is there. So only heat transfer from absorber plate to the uh, uh, outer glass only by the radiation is there. There is no convection is there. So by minimizing the convection, it can retain the heat when we receiving the solar radiation over there. So in this type of the solar thermal collector vacuum flat plate collector, the temperature of the absorber plate reaches up to the 350 degree temperature. So this is one of the example of the vacuum technology. So in the evacuated tube collector is there, where we have the vacuum, there is no air is there, so it can retain the heat absorb into the heat pipe, so it can transfer the high density heat to the fluid is there. So working fluid temperature reaches up to the 200 degrees centigrade. So basically the basic principle of the heat pipe used in the evacuated tube collector, there is a two hand is there, one is the hot end, one is the cold end. So in this there is a one fluid is there at the hot source where we are getting the heat, it's get evaporated and traverse on the other end, and it's by the capillary action, capillary actions, it further reaches to the hot end by the fluid and evaporate. Though there is a basic heat pipe, it has a high thermal conductivity. So the other thermal system that can be used into the building, that the compound parabolic collector that uses the reflector is there, which can concentrate the solar radiation on a particular an energy absorber system is there. It has a evacuated tube collector. So its working temperature of the fluid reaches up to the 200. It utilizes the direct radiation and radiation that reflected from the this reflector is there. So other technology that we have, the photovoltaic thermal collector that utilize the PV panel as well as the thermal technology. So the PV panel that can generate the electricity, and the thermal system that is attached to the PV panel can generate the thermal energy. So it is a dual purpose system. By the single system, we can generate the electricity as well as the thermal energy simultaneously. So this is the one advantage. The other advantage of this system is the when the temperature of the solar cell is going is high, so the efficiency of the solar panel PV panel is too low. So by extracting the thermal energy from the PV panel, its efficiency improved. So we are improving the solar uh, efficiency of the PV panel, and we are extracting the thermal energy of the system. So these are the dual purpose, and this is the parabolic parabolic thermal system, where we have the big reflector and we have the absorber plate is there. So we are the throw concentrate sunlight onto the receiver that is positioned along the focal line of the throw. The reflector, this is the single axis of the collector. We can rotate the reflector in this direction like this. So we can positioning of the reflector according to the sun position. So it can be tracking system, and it can be fixed. So it can reflect the solar radiation on a particular thermal energy absorber. So we can utilize the solar energy into the building for heating purpose also. Basically, this technology is very popular in the Ladakh region, where we have the sun radiation direct. We are receiving the sun radiation through the window. There is a mass thermal mass is there. So in the daytime we can receiving the sun radiation through the window, and we are heating the thermal mass placed below the floors. So in the daytime it can radiate the heat which is absorbed in the daytime. So in this way we can manage the we can maintain the temperature into the space. So other point, the major placing of the facade is plays also important, because in the summer where we do not need the sun radiation into the building, so it restricts the area of the sun radiation falling into the building. But in the winter we need the maximum amount of the solar radiation that reaches up to the certain area. So in this way we can uh, we can design the facade or shading device into the building. So these technology are for the heating purpose. These technology are very popular in the Ladakh region. We have the bigger facade, bigger windows is there. We have a large amount of the solar radiation falling into the receiving into the building floors. So there is a other thermal system that indirect solar heating. So we have the flat plate collector, we have the circulating fluid is there. We can store this thermal heat transfer fluid at a high temperature, and we can utilize to heat the building. So in the indirect solar heating, we can utilize the radiant solar heating. So in the radiant solar heating, this method is intentionally using the principle of radiant heat to transfer heat to transfer radiant energy from the emitting heat source to an object. This provides an improved climate and healthier humidity levels. The maximum temperature of the heating surface can vary from 29 to 35-degree temperature. So in this way, we can exchange the heat from between human and the panel which are placed on the wall, on the ceiling of the building is there. So there is no need of the air system is there. We not need to circulate the air into the space. We can exchange the heat from human to the panel. Radiating panel is there, so it has a high efficiency in comparison to the air based cooling and heating system. So other system is the solar window previously in the solar window has been utilized for heating the in the building. This system is developed at the CBRI. Is one of the scientists from the CBRI. So these are the some graph is there. So you can see the by using the blackened aluminum sheet and the perforated blackened aluminum sheet. You can see the in case of the perforated blanket sheet, the temperature indoor air temperature is uh, higher in comparison to the blackened aluminum sheets. So basically, it's absorb the heat from the solar and maintain the room temperature. So the energy that can be utilized for the building in the form of the cooling. So these the system that can utilize the heating for heating thermal energy for the cooling purpose. For this, one of the vapor absorption system is there, so it can uh, generate the cooling from the waste energy or the solar energy system is there. So it is very popular system is there that can be utilized for cooling into the building. So other is the desiccant based cooling. So in this desiccant based cooling, so in this technology we in the CBRI we work together. In this we have the thermal system, thermal where we have three major component is there. One is the uh, thermal collector is there, one is the desiccant wheel, and one is the uh, indirect evaporative cooler. So these three major component being used in the desiccant based cooling system. Basically in the uh, direct a desert cooler in which the air is passed over the uh, cooling pad, so it increase the humidity, but it's cool the spaces. But in the desiccant cooling we have the supply, we have the supply air. It can extract the heat, it can extract the heat it can extract the heat from the desiccant wheel by removing the moisture from the incoming air, and this dehumidified air is further cooled down by the heat recovery unit and uh, by the indirect evaporative cooler. So we are doing two process for the incoming ambient air. In the first process we are removing the moisture, we are dehumidifying, and in the second process we are cooling the reducing the air temperature. So in the return air we are taking the heat from the space, and we it regenerate the heat into the desiccant wheel by heating this air. So by heating this air by the thermal system, thermal energy, we increase the temperature of the return air, so it can remove the whatever the moisture is absorbed in the desiccant wheel. So we are regenerating the desiccant wheel for further use of the dehumidification process. So basically these are the three major component: thermal collector, desiccant wheel, and the indirect evaporative cooler. So basically, desiccant is the chemical. Desiccant is the material that used for the absorbing the moisture from the present air, remove the moisture, reduce the humidity, improve the air quality. For comfort level, 23-degree temperature we have to maintain with the relative humidity of 55, around 55 degree. So we are in this technology, we are removing the controlling the moisture into the air, and we are controlling the uh, temperature of the air. So basically, desiccant wheel, you can see the dry air, incoming air has the moisture. So we are reducing the moisture from the desiccant wheel, and we are returning air. We have the returning air from the space. So we are heating this, and hot air can supply through the this wheel. So it can remove the moisture for the regeneration process. So basically, the indirect evaporative cooler has the several advantage. It do not increase the heat, do not increase the moisture, and maintain the humidity into the supplied air to the space to be cooled. But in the desert cooler that have the direct evaporative cooler, uh, we cannot control the humidity into the moisture. So this is one of the technology that we can integrate into the building or even the agriculture. Solar air heater that remove the moisture from the air, and it can be heated. So basically it's dry the crops, it dry the space which need to be heated. We can utilize this technology for in the winter also for heating the spaces into the building. So the drying is a so this it is a very popular technology that particularly for drying the crops or for even in the preservation or storage of the greens. So basically, in the solar air heater, we have a simple design. We have the absorber is there. Below the absorber, we have the air passage is there, and we have the glass. So when the radiation is falls over the solar absorber through the glass cover, so temperature of the absorber is high. So the air incoming air extract the heat from the air and transfer to the here, absorb plate, glass cover, insulation, air flow passage blower is the main component of the solar air heater. So it is the basic design. So nowadays, very advanced solar air heater are available into the market that can be utilized into the building for various purposes. So one of the solar cooker that is developed at the CSIR CBRI. So this solar cooker can be used as the dryer. So solar cooker have a insulated box topped with the transparent glass or plastic cover, and it has a reflector that help the maintain the heat into the this in the boxes. So cooker can cook two items at a time: dal, rice, or can dry the vegetable or fruits. So the it is to very cheap system is there. So these are the some uh, drying of the vegetable. We have the data. So it's take 3 hours to reduce the moisture content 80%. So these are the we can dry the potato, cauliflower, tomato, chilies, banana, guava, grapes. So this is very useful for the household. Even we can make the rice, dal, or different boiling meals we can cook in this system. The trombe ball is the solar thermal system that can be utilized into the building to reduce the to reduce the dependency on the fossil fuel. So in this trombe ball we have, it can be used for the ventilation, it can be used for the heating the space. For the ventilation, you can see we have this collector. This, when the radiation is fall, it's get heated. So when the when the air is in contact with the this thermal system, so it's get heated due to the density difference. It's when that density difference is there, it's it transfer to the hot air, transfer to the hot air, and its relief. So there is a, it's create a natural stack at the bottom. So by creating the natural stack, it sucks the fresh air. So in this way we can utilize the natural ventilation by using the trombe wall. So there is another example of the tombe ball in the form of the solar chimney. So solar chimney is referred to the as a solar thermal chimney. This is the way of improving the natural ventilation of the building by using the convection of the air heated by the passive solar energy. A simple description of the solar chimney. So in the solar chimney we have the uh, ground heat uh, tunnel is there. So in the ground this tunnel maintain the temperature of the incoming air. So in this is the thermal system. So we have thermal system. When it's get heated by the solar energy, it can utilize the energy to heat the air. So when the air is released from the chimney, it creates the suction. So we have the earthen channel is there. So it's suck the air through the earth. So the temperature of this air in the earthen channel, it reduce. So it reduce the temperature, and it's also create the ventilation into the building also. So the other system that can be utilized into the building is a solar distillation system. Solar distillation system, that is a simple design uh, that we have only the glass cover and box is there. So we have the contaminated water is there. So by evaporation, by utilizing the solar energy is collected at the one end. So we can reduce the contaminant from we can eliminate the contaminant from the water. Uh, and we can purify the water by condensation and collection at the one end. So this technology that can be utilized, there is no need of the any external power to operate this. So basically these are the system we can be utilized into the building, not into the building. We can utilize these system in our daily life to reduce the dependency on the fossil fuel or the electricity supplied through the grid. So these are the linear frontal reflector that can generate the electricity by means of the solar energy. So in this solar solar thermal system, the it has a long frontal reflector for use. There is a small portion is the reflector there. It can reflect the solar radiation on a particular linear absorber. So it can reflect the all the radiation falling on the reflector on a particular absorber. So its temperature reaches it approximately 30 times constant ratio in comparison to the flat plate collectors. So it can generate the high thermal energy to drive the turbine for generation of the electricity. So these are the parabolic dish reflector. Parabolic dish reflector collector. It is form of the uh, form of the dish reflector. In the form of the dish, it can reflect the solar energy at solar energy at a particular area. So it can reduce, it can accumulate the energy at a high temperature. So this energy can be utilized to drive the solar power plant or other steam based thermal plant. So basically these are the technology to utilize the solar thermal energy to generate the electricity. So these uh, central tower receiver is one of the example of these technology. So in the solar tower receiver, we have a one receiver and there is a large array of the refractor is there in the solar field. The all the solar radiation is reflected at the solar radiation on a receiver uh, receiver located at the top of the tower absorb the solar energy concentrated by thousands of the mirror on the ground. So this technology is efficient for heating the molten salt and other heat transfer fluid. That for direct uh, operation of the steam generation that can be utilized for steam uh, base turbine to run the generator to produce the electricity. So basically in this steam based solar thermal plant we can utilize this technology to generate the thermal energy to generate we are generating the electricity indirectly by conversion of the solar thermal energy into the electricity. This is the another technology where we can utilize the solar energy in the form of the electricity. In this, we have the large ground for the solar chimney. We have the large collector. So in this, we have a large area array of the solar system. So we have this is the solar absorber is there. So below is the energy, below is the air is passing due to the heat accumulated into the build into the below the absorber. So it get heated due to the density difference. It goes up and it drives the turbine to generate the electricity. So basically, these are the technology to drive for the generation of the electricity. These are the PV technology. These PV technology it's very useful. It can be integrated into the glazing of the window. Basically, these other transparent PV cell is there. So you can see the it can generate the electricity. Also, it can behave as a transparent window glasses is there. So uh, it's it serves the dual functions. It can be utilized into the building where we need the simultaneously natural daylight and we need the electricity generation by these module. So other technology for can be utilized into the building that the solar paint in the this paint can be can be replaced the normal paint of the outer surface of the building where we it can generate the electricity. This paint combines the titanium oxide already used in the many wall paint with the new compound, so it can generate the electricity and serve as a paint of the building on the surface exposed to the solar radiation. This is one of the technology for solar tree is developed by one of the CSIR lab. So It is a solar tree structure type where the solar modules are planted on a single pillar which look like a tree trunk. It serves a dual purpose for being a artwork and energy generator. So it can save a lot of land basically. So when we place the solar panel onto the on the ground, so we cannot use land for the other purpose, but these technology it can be utilized for the dual purpose. We can use the land for the other purpose in combination with the generation of the electricity. So it gives 100 times more solar power compared to the solar PV layered consume only 1% of the land surface for the same powers. So it holds the panel at a higher height, get more sun. Uh, so basically, these the main purpose of this technology to save the land while using the solar uh, power generations. So in the tri generation that are very common into the building, so basically uh, we need the uh, energy in the form of the cooling of the building, in the form of the electricity, in the form of the heat. So basically, generation serve the all the purpose for the building. So tri-generation like a single fuel can generate the electricity, can produce the cooling into the building, can produce the heating into the building. Though tri-generation is a attractive option in situation where all three form of the energy needs uh, and simultaneously produce the cooling requirement, fulfill the cooling, fulfill the electricity requirement, fulfill the thermal energy requirement. So basically, the different kind of the generation system is exist and can be employed into the building. The basic is the ORC operated and under a low operating temperature. So in this organic Rankine cycle, it's not only generate the thermal energy, it can generate the electricity, it can generate the cooling for the cooling purpose into the building. So geothermal is one of the promising technology to not only for the cooling of the building, but it can be used or heating into the building. Basically, the it exchange the heat. It can exchange the heat from the ground to the from the building to the ground. The main concept behind this exchange between the ground and the space, the ground temperature is uniform throughout the year, and it's do not deviate throughout the year. So the it is not so hot, it is not so cold. So it's basically minimize the temperature difference from building to the ground level. So by exchanging the heat from at a minimum temperature difference, so it the COP of the system is too high, not only in the cooling for also for the heating system also. So this technology is very useful where we have a moderate temperature of the grounds. So basically, these are the some technology that we can be utilized into the building. We have discussed the solar thermal system. We have discussed the geothermal system. We have discussed the many solar system which can generate the electricity. We can generate the natural ventilation by the solar energy. We can generate the cooling, we can generate the heating for the building. So basically these active system that is the renewable energy we can be utilized into the building to fulfill the rest part of the energy that remains uh, unsatisfied by the passive parameters. So basically, now I would like to discuss the star rating for the building, that you have aware that the different system that's come in present into the market that have a star rating is there. So these star rating these star rating not only for the developed for the AC, refrigerator, washing machine. It is also developed for the building also. So there is a different star rating available into the in the India like building energy efficiency star rating for building green rating for integrated habitat assessment, Indian Green Building Council rating, leadership in energy and the environmental design. So these are the four basic uh, star rating for the building available into the India. So we will discuss the most popular star rating for the building. It developed by the Building Energy uh, Bureau of Building Energy Efficiency. So the star rating performance of the building is based on the actual performance of the building in terms of the specific usage kilowatt hour per square meter per year. So basically buildings has been these star rating has been labeled from 1 star, 2 star, 3 star, 4 star and 5 star based on the and specific energy usage into the building. These building has been categorized into the different usage of the building like office building, hostel, hospital, retail malls, and IT park in five a climate zone in the country that have been identified. Identified office building in the following. The office building has been categorized into the three climatic zone for air conditioning and non-air conditioning. So these uh, air conditioning, non-air conditioning, the star rating of the air conditioning, non-air conditioning has been star rating developed for the warm, humid, composite, and hot, dry climate. So basically, these are the two type of the office building is there. One, we have the office building which has less than 50% air conditioning and which has more than 50% conditioning. So basically for the hot and dry, warm and humid composite. So when the EPI 65 to 70% of the building in the hot dry climate, when the conditioning building has the 50% air conditioning. So 1 star building is there, 2 star building when the API range 55 to 65. So there is a for the different climate zone, warm, humid, composite. When the HVAC system has 50% high air conditioning, then API range is suddenly increased because when the air conditioning is there, so it's consume lot of energy. So for considering that point, so API range is increases. It's increases for 65 to 75 in case of the building has the less than 55% air conditioning, but in case of a 155 to 185 API for in case of the air conditioning has more than 55%. So these are the different API ratio for hot and dry, warm, humid, and composite climate. So star rating for BPO building AHEPI. So basically, these for the star rating for the BPO building where we have a 5 star, 4 star, 3 star, 2 star, 1 star, and these uh, data refer to the warm and humid, composite, hot and dry, and temperate. So on the basis of this data, we can decide whether the building is 5 star, 4 star, 2 star, 3 star, or 1 star. So basically, there are a few example of the building that has the green building or net zero building. So first one is the green building in the India. The first in Indra Paryavaram. Paryavaran Bhavan. So it is the 7 stories building plus 3 basement. So it has a PV rooftop. It has a geothermal. So it has a net zero building as per the building rating. So other buildings, the Godrej Plant 13 NXE. So its EPI is much below the projected EPI, or it is a 5 rated building that's available in the constructed into the in the Pune. So this is the other building that is Infosys campus. So it is a 2,40,000 square feet Infosys office in Hyderabad, showcasing the innovative cooling strategy using the half radiating cooling and a half standard VAV standard. The radiant selection uses 30% less energy than the VAV despite the higher occupancy. So we have already discussed the radiant cooling is highly efficient than the air-based system. Though this building design which include the insulated envelope, shaded device, natural daylight, enhancing yeah, sorry, designing the building envelope so it reduce the energy consumption in the building. So this is the green building. So with this, I am stopping here. So if anybody have any question, any doubt, so I will be happy to answer your queries. Hello,
Hello.
hello.
Yeah, participants, if you have any query, please ask the experts. So come.
If you can write into the chat box also, if you have any issue with the mic or other things.
Sir, what would you like to elaborate about the thermal PV paste?
Thermal PVT,
PV paste,
PV paste or PV paint.
PV paint or paste, whatever it is.
That PV paint, like the team of the researcher from the Korea, they developed the paint like a simple paint, so it can be pasted over the wall, so it can harness the solar energy into the form of the electricity, but the efficiency the is too low. So the people are working in the good direction to develop. Suppose if so uh, in the present scenario we have the PV panel, so we have to place over the roof or the land. So these technology are very useful for the scenario we don't have access to the roof of the building, so where we can use the paint over the wall or the roofing, so we can increase the exposed area to the sun radiation. In this way we can utilize the generation of the solar energy from electricity from the solar energy.
What about a gridding for this paint? How we can connect in series, parallel, etc.
Hey, basically, it is not into the market right now. It is in the developing phase. So a
Okay.
small portion has been developed. Its efficiency to 3% only is there. है ना? So people are working in this direction. So these are the future technology. Not it is being commercialized right now, but this would be the future technology.
Now in these days there are flexible PV panels.
Flexible PV panel is there. Yes.
how they are working and how they can be folded?
Actually, PV panel, like you have a layer of the silicon material. So there is a different kind of the technologies is there that can be this cell can be flexible. So there is a small cell is there that can be integrated with each other. So it can make a large area. There is a not a single cell, it is too small, but there is a array of the cell is there, so it can make the large area. In this way we can uh, integrate the small flexible cell into the large one.
Is
Large,
this technology has been commercialized?
it is available.
Okay. PV paint is not commercialized. It is in
No, no,
experimental
no, no,
stage
no, no.
still.
Actually, this system has a very small efficiency. 2 to 3% is there,
No,
so it is not
from the
very.
research point of view, it is the new
Ah,
technology.
yes, yes, yes. This new technology, other technology, the transparent glass is there.
The same
So,
process in paint, how the is the grid is pasted on the wall and then painted, or what is the concept?
hey, it is pasted on the wall, on the surface.
But it should have the grid. It should
No,
have
not.
the conductors inside the paint.
Yes, yes, yes. That should have the conductors.
But painting means it is a discrete mechanism painting, and the grid is the continuous process.
Actually,
Right?
you have seen the circuit, na? So you have electronic circuit. You have seen. So there is a layer is there of the conductive material is there, है ना? So there it is a flexible. So actually, uh, in this technology, the very sophisticated conductor is integrated in that. So it is not the simple paint. A simple paint is just paint by the brush, but it is not like that. It is a special treatment is there. You need the special requirement. You have the special procedure for testing this paint.
So is it like poster pasting like that one or something different? I couldn't understand the concept of this thermal paste or PV paste, sorry,
PV paste, not
paint.
a it is PV paint.
Okay, okay, yeah, PV paint.
In PV paint, there is a what is the material? Silicon is the material.
There may be.
हाँ, basic is the silicon is the material, है ना? So it can be pasted anywhere, but there is a procedure. There is a some component, additional component is there, like conductor, like connector, but different, but they are too small. They are so sophisticated uh, that cannot be implemented by the simple technology. So these are the these are the underdeveloping phase, but people are working on this technology.
I'm talking about the principal part only. Not
Principle is the same.
no PV making the holes and electrons movement,
Ah,
but
same
how to
procedure,
collect the
same
electrons and how they the movement of holes is taking place. That is the question.
same procedure is there. There is
But that one is the paint, na. The
हाँ
problem
हाँ
is
in the PV panel
so
there is a
first
small
we
layer is
either
there
we
na.
either we pay either we install the some gridding mechanism or conductors on wall and then we paint it or like that or different one.
Hey, basically it is not they publish the paper, but it is not on the tested on the wall. They are particular surface, है ना? Particular surface. So you can refer that paper what they have been adopted technology, है ना?
Maybe
So you
already circuit printed on that surface.
maybe already circuit
Means
printed
it
on
is
there.
not clear that how it is producing the energy or electricity.
I can send you the paper. You can refer that whatever the technology they use,
Okay,
because
thank you.
it is not commercialized till now, so we cannot comment over it.
Commercialization is different issue, sir. The
Yes,
concept
yes.
and research is different.
So
Commercial, it may be.
concept is
Earlier
the
one, silicon cells were also not commercialized. Now in these are everywhere used in